Hey everyone, Mr. Skelton here. We are back at it. We are actually starting Unit 2. On your notes it'll say it too. Mine's an old one here. But yeah, Unit 2, this is Assignment 1 in Unit 2. And we're going to begin our study on systems, okay? Systems of equations. If you want to know what a system looks like, take a look at the examples on the third page. This is an example of a system. Here's a situation where you have two unknowns, x and y, with two equations. We'll get into some problems where we have three equations and three unknowns, but this is Algebra 1 stuff, so you will probably recall this information because this is a pretty big unit and we spend a lot of time on it in Algebra 1. So let's do a couple of review things real quick with systems. First of all, there's three ways to solve that you learned in Algebra 1. One is graphing, which is what we're going to focus on today. Today is solving by graphing only. Number two is substitution, and we're going to learn that in a couple lessons. And the third one is elimination. Okay? And seeing those words may recall your memory. Now, graphing is a way that we teach how to solve systems, but it's the most inaccurate. All right, it's the most inaccurate because it requires you to draw things by hand and try to find intersection points, and that's not always easy to do because of human error. Substitution and elimination are the most commonly used when solving systems, okay? But we're going to get into some graphing. This will be a good review for you anyway. So I got an example down here, kind of a real-world application, Kings Island versus Cedar Point. My preference is Cedar Point. But it says Cedar Point charges $14 to get in plus a $4 ride, so write that equation. That would be y equals, where's your rate? 4 here, so it would be 4x, because it's $4 per ride, so x would represent your ride, plus the $14 flat fee. Kings Island, on the other hand, is $2 per ride and $32 to ride to get in. And so it'd be a situation like this. This would be the question, you know, how many rides would you have to ride in order for the cost to be the same? That would be kind of the situation that would be expressed to you on a problem like this. So what we want to do is, we probably wouldn't want to graph this because there'd be a lot easier way, like substitution, but we're going to try to graph it anyways, okay? So let me zoom in here just a touch here for you. And I'm going to make my graph on my x values. Since my x values are fairly small, I'm just going to go by increments of 1, so 5, 10, 15, 20, 25, and 30. Because my y values are rather large here, I'm going to scale this just a touch. I'm going to go by 10, so by 2, so 2, 4, 6, 8, 10. I got 20 here, and I have, let's see, 22, 24, 26, 28, 30, and this should be 40 up here. So I scaled it just slightly on my y-axis. So you're just graphing these linear equations. If you graph the equation number 1, call that equation number 1, start at 14, so here's 10, 12, 14, and then my slope would be up 4, so each of these are 2, so up 2, 2, 4, and over 1, which works out okay, so right in here. And I'm going to use a straight edge here to kind of graph this. And then I'm going to graph this one here. So I'm going to start, my y-intercept is at 32. So here's 30, here's 32. And then my slope here would be 2. So I'm going to go up 2 units, which would be here, and over 1, which would be right there. Now, this probably isn't the best example. Let's see if this is going to work for me. I probably could keep going. And you can see that they intersect. Now, the whole point of solving by graphing is to get your lines to intersect. Now, I obviously am not close because right here it should be at 9 and 50, and my graph's off just a little bit here. Let's see, 14, that was 14 there, and then I went up 4, so 2, 4 over 1. I'm going to be, it should be over here where 9 is at, so I'm a little off, but again, I didn't do my graphs properly. This one's probably supposed to go, you can see it's probably supposed to go that way just a little bit. Hence why graphing is inaccurate, okay? But this intersection point should be at 9 and 50. And wherever the two graphs intersect, that is your solution. So when you're solving by graphing, all right, you're looking for the intersection point. That's going to give you your answer, okay? So let's turn the page. And let's talk about some different situations that you may see when you do the assignment and what solutions they will yield. So We have three situations here. We have the first one's called independent system. When you have an independent system, that's where you have one solution. That's what we had on the last page, okay? You have different slopes. So if I recall, it was y equals 4x plus 14, and then the other one was 2x plus 32. The slopes are different. This has a slope of 4, this has a slope of 2. They're going to intersect. They intersected at a point which gave me my one solution. And that one solution is always going to be an x comma y because we have x's and y's that are unknowns. Now, the second type of situation that you may come across is what we call a dependent system, and that's where you have infinite amount of solutions. That's where when you graph them, it's the same exact line. Remember that a line is just a bunch of points together. So if you have a line, which is representation of a bunch of points next to each other, and you graph that same equation and it falls on top, every single point here, 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 here. This is an example. You can see the two different sets of arrows. So set A, or this example A, would be example 2. Independent system, I'll go back here, is B. It's kind of like matching here. Okay? And then the last situation is what we call an inconsistent system. If it's inconsistent, it has no solutions because the lines are parallel. And if lines are parallel, right, they're never going to touch or they're never going to intersect. So there's no way there can be a solution. And that's when you have the slopes being the same. So like y equals 3x plus 1 and y equals 3x minus 7, right? Those have the same slope of 3, but they have different y-intercepts. So when you go to graph these, they're going to be parallel lines and they'll never touch. Okay? That'll come into play as we go through. So let's take a look at some examples for us to try. So I'm going to graph the second one first since it's already in y equals mx plus b. So I'm going to go up 4, 1, 2, 3, 4. And then I'm going to go down 2. Right? There's your slope, down 2 over 1. So down 2 and over 1, down 2 and over 1, down 2 and over 1, down 2 and over 1. And you could repeat that all the way through. If you want to take your straight edge, you can do that. See if I can make this a little bit more accurate than my first attempt at my graphing. Now, if you notice on the second equation, that's in standard form. Now, if you remember how to graph in standard form, you can go ahead and do that. What a lot of students are going to do is solve this for y, or they're going to put this into y equals mx plus b. And so what we would do is subtract the 3x to the other side, so we'd have 9y equals negative 3x minus 9, and then divide everything by 9. And we would get y equals, that's going to reduce to a negative 1/3 x minus 1. So that's what we want to graph on our paper. So there's negative 1. And if you have a negative out in front of the fraction, you can put it on the top or the bottom. So I usually like to put it on the top. So that means I can go at negative 1 and then go down 1 into the right 3. 1, 2, 3. Well, what do you know? I can make my straight edge right now from here to here. And again, we're looking for where the lines intersect, and that looks to be that point right there, which is 1, 2, 3, and down 1, 2. So that would be 1, 2, 3, 3, comma, and then 1, 2, negative 2. Now, once you get a solution, what should you probably do? We should check it, especially when you're graphing because of the human element that's involved in graphing by hand. So, for example, if I take this equation here, plug in a negative 2 for y, I get negative 2 times 3, which is negative 6. Negative 6 plus 4 is negative 2. Check. And then do the same thing here. 3 times 3 is 9, plus 9 times negative 2, which is negative 18. Negative 18 and 9 make negative 9. Check. So check and check. It worked for both. Boom. That is your solution. Okay? Why don't you go ahead and hit pause and try number 2 and see what you come up with. Okay, so before I even graph this second equation, I'm going to go ahead and put that into y equals mx plus b like I did before. So I'm going to subtract the 4x to the other side. And when I do that, I'm going to have negative 10y. Some students will just neglect this negative sign and think that it disappears when I subtract the 4x. That's still a negative 10y. So it's negative 10y equals, and again, since we're putting it in slope-intercept form, I put the minus 4x first. And since that's a positive 20, that gets the plus 20. Now I'm going to divide everything by negative 10. And be careful of your signs here. I have a negative 4 over negative 10. 4 divided by 10, if you divide by 2, that reduces to 2/5 x. And 20 divided by negative 10 is minus 2. Now, what do you notice here? Well, I just took this first equation and it turned exactly into this. So yes, we're solving by graphing, but what about the answers here? What is this going to be? This is the same exact line, so this is going to be an infinite amount of solutions, all right? And if you graph it, you know, down 2, boom, there you go, up 2, 1, 2 over 5, 1, 2, 3, 4, 5. And if you make your line, I'm not even going to use my ruler here. And if you go to graph the other one, it's going to sit right on top of that. So every single point on this line is a solution because it's intersecting itself, okay? And this one says, example to try with your graphing calculator. So we're going to grab our graphing calculator, and hopefully I can get rid of a little bit of the shine on it. And still you can see it. There we go. And I'm going to move this up just a touch so I can get the whole thing in there. I'm going to back out just a touch. One more. Perfect. Okay, so turn on your graphing calculator. And I always like to reset my memory just in case anything's been stored. You have a mem button right here. It's the plus sign. It says MEM. So I'm going to go second mem. And I'm going to hit the number 7, which says reset. And it'll say all. Just hit enter. And it's going to say yes or no. And go down to reset. Hit enter. And it'll say, oh, your RAM's cleared. So that just clears your memory. Perfect. Now, if you're going to graph these, if you hit your y equals button, you're going to type them in. Now, you'll notice on the left-hand side here, it's all in y equals. So what you're going to need to do with this equation here is put that into y equals mx plus b. So subtract the 2x. That'll leave you with minus 3y equals negative 2x plus 6. And then divide everything by negative 3. And you get y equals 2/3 x minus 2. And that's putting it in y equals mx plus b. And you need to do that if you're going to plug it into your graphing calculator because it's in y equals. So let's do this. Now, when you're plugging in fractions, I always use parentheses. So I'm going to put parentheses, 2 divided by 3, close the parenthesis. And then to get an x on that, you hit this button right here that has xt, theta, and n. You just hit that button there. There's your x. And then minus 2. Okay? And then you can just hit the down arrow key. And that brings you to your second equation. So now I'm going to put in this one here, that y equals negative 1/2 x plus 5. So I'm going to, again, since it's a fraction, I'm going to use parenthesis. I'm going to put my negative sign. 1 divided by 2, close parenthesis, hit my x, and then plus 5. And then once they're in, I'm just going to hit graph. And there's your first line going across. And then your second line should come across there. Now, not always will you get nice, neat integers. Now, we can obviously see where it crosses, but we want our graphing calculator to tell us exactly where it crosses because you can get decimal answers. You can get messy things. So how do we do that? Well, right above your trace button here, your trace button is located there. The word says calc, C-A-L-C. It's in yellow. Anytime you want to access your yellow functions, now, again, your calculator may be different, but I can help you with that. We want to hit second trace, which gets to our calculate function. And you'll see if you scroll down to down arrow key down to number 5, we want to do the intersect function. So hit intersect and then hit enter. And it's going to say first curve. Now, what this is basically doing, if you move your right and left arrows, it's basically asking you, hey, student, is this the first curve you want me to calculate? You'll just hit enter, yes. And then the cursor will jump to the second curve, and it says, is this the second curve you want me to calculate? Because you could have a situation where there could be more than one line, and you just want to calculate maybe 2 of them. So it's kind of a known thing that these are your 2 curves, but your calculator just wants to make sure. So hit enter again, and then it'll say guess. You don't want to guess, so just hit enter again. And it's calculating, and there's your intersection point right there, 6, 2. And so our answer to this one is 6, 2. All right? On your homework, I would like you to dabble with the graphing calculators just so you can kind of get an idea how to use it. But I also want to make sure that you can graph things by hand as well. So I'm not going to tell you which ones to graph by hand and which ones to use a graphing calculator for. Maybe just do a mix, okay, and go from there. So again, this is our first lesson of Unit 2, and we're focusing on systems and specifically graphing. We'll get into substitution and elimination later, okay? All right, I hope you have a good rest of the day, and I'll check with you when we get to class.